So in this problem, we're asked to determine divergence or convergence using this series here, where we have n squared over n to the third minus 1. Now, there's a couple ways you can approach this problem. Now, what we're asked to do is do a comparison test. But first of all, this is the thinking you need when you're asked find convergence or divergence for a series is first take the, the divergence test. Take the limit of the sequence of terms in your series. The divergence test here is going to say, what is the limit as n approaches infinity for n squared over n to the third minus 1? We know that if we evaluated this, it would be indeterminate because you'd have infinity over infinity. So we're going to do L'Hopital's rule. Well, just once to start, but we'll see that we'll have the same problem. Notice we have the same problem when we take L'Hopital's. If we evaluated the limit now, we'd get infinity over infinity. We don't want that. So what happens next is we take another L'Hopital's rule, and we're going to say that 2 over 6n minus 1. So this is 2 over infinity. This is 0. Now this is this is indeterminate by the test we just did, the divergence test. Therefore, we cannot say for certain if it is divergent or convergent. We can take a guess, we might be right, 50-50 shot, but you can't really tell when your output of the divergence test is 0. All right, so we don't really know if it's divergent or convergent. What's next? Well, there's two things you could do. You could look at that and say, oh, that's a natural log integral. It's actually 1/3 ln xn to the third minus 1. You could do an integral test and easily use an improper integral idea to find convergence or divergence. But here that's not what we're asked. We're asked to use a comparison. Now I'm going to notice that, okay, well, I'm going to notice this and I'm going to say, okay, constants are not going to help me out here. So I'm going to omit the constant and say, what is n squared over n to the third? That's simply 1 over n, right? Okay? What is that? That's a harmonic series. And we know that that is going to be what? Well, we know this will be divergent, right? We know all harmonic series are divergent. But let's compare it to n squared over n to the third minus 1, okay? What really is this? Well, let's think about it. This is the same as n squared over n to the third, but notice we're subtracting 1. Okay, what does this actually tell us? Well, think about it. If we are subtracting from our exponent, if we have, for example, 1 to the third, and we subtract 1 from here, that's going to make it 1/2. And we know that 1/2 is a greater value than 1 to the third. 1 to the third is not as great as 1/2. Unless you really like 1/3, and then it might be that great. I don't know. But basically, this idea is saying, well, if this is equivalent and we subtract 1, this is always going to be greater. Okay, and this is perfect for a comparison. If we say that this harmonic series is divergent, think about it as a graph. Okay, I'm going to grab a new marker. So this is going to be the blue curve, okay? We know that this will be divergent if it was like a graph plotted. But what would this be? This is greater than, okay? And if it's always greater, it must follow these bounds. This should be a lower bound of our series. So it will diverge as well. Do you see the idea? Notice, this is less than it, so it's below. If it was a curve, if we plotted the curve, it'd go whoop. All right, but notice that it's divergent. If this is divergent, well then this must also be divergent. So what we can say here to solve our problem is, okay, notice that this is a harmonic series, and we'd write the following logical proof. Because 1 over n is, and sorry, you would want to write this as a series as the series from infinity to n equals 1 of 1 over n is divergent, and the series infinity to n equals 1 of n squared over n to the third minus 1 is greater than the series from infinity to n equals 1 of 1 over n, then our initial series is also divergent. So notice my logic here. We did this comparison test, and we said because this function is divergent, or this series is divergent, and we know that this series is greater, well then this series must also be divergent, using the logic we talked about. You'd probably want to give your answer like this, as like a statement, saying, okay, because of the comparison test, this is true. Anyways, that's going to do it for this little episode here. If you enjoyed, please drop a like, comment, and subscribe. I would greatly appreciate it, and I hope that you have a wonderful day.